My name is Akil and this is my smart school environmental system for smart classroom. So right now, let me just reset it first so you can see the whole system. So I have a PIR sensor. When there's motion here, right. When there's motion here, see motion is detected and the fan is on. The fan is based on the temperature sensor here. So if the temperature sensor is moved on 25 degrees, the fan will be turned on. Now I have a door here, an electromagnetic door. So if I press a button here, the door opens. So now as you can see, I have an innovative idea here. So I have two sound sensors, sound sensor 1 and sound sensor 2. So let's say we are in a classroom and we have an exam going on. And right now we usually in any exam hall we need at least two lecturers monitoring the whole class. So in case of having two lectures, we only have one. So how do I do that? So let's say a lecturer is sitting here. You can see here, let's say the lecturer is sitting here. Sometimes they can't hear people from the back, right? So we can't get people from the back. So I have a sound sensor here. So like I'm talking right now, you can see it says possible cheating because I'm talking, right? Possible cheating. So because I'm talking, it's kind of like detecting any noise from like where the sensor is. So in a classroom there'll be like multiple of them. So yeah, this will detect any possible cheating. And now motion again. Yeah. Now my second innovative idea is the two sound sensors. So let's say both my sensors here, sensor 1 and sensor 2, are detecting some kind of noise above a certain threshold. Both my sensors would say, as you can see, if I do, it says the ambient noise is too much. So now we will play a small noise, a white noise on this speaker here, which should basically reduce the noise in the classroom. According to a study, it was 40% of students found that the noise is too much. And yeah, so I can close the door later on.
My name is Sharvin. This is my individual circuit. So this is the emergency system for the smart school system. So as you can see here, I have hallway lightings, my emergency exit lightings. I have a buzzer alarm, flame sensor, LCD, and this is to replicate a sprinkler system. So the working concept of how this is going to work is, let me show you. So first, when the flame is triggered, you can see lighting, and you can see here the relay triggers and sprinkler comes and water comes out. Okay, you see the lighting here, the top lighting has become dim and the bottom lighting to show the exit path has been littered. So what this replicates is an innovative concept taken from the airplane takeoff and landing system, because in schools I've done my research on and I found a research paper that says that students have no clear indication of where the exit paths are. So by using this concept, it can point students towards the nearest exit lighting. And also I have the sprinkler system here to put out any fire. The buzzer will sound to let students know, and the LCD, which will be displayed in the hallways in the classrooms, will let students know. Yeah, that's it. Thank you.
This is my smart ventilation system for the smart school. I'll start off with showing you this my LCD to show the alerts. This is my OLED to show all the details of the sensors. Power supply, kill switch, my two sensors, humidity and temperature sensor, gas sensor, and then my ESP32 and my motor driver. This is my exhaust tower, and this is my enclosed area. It's a cup, like to simulate like an enclosed classroom or a place. And this is my air vent. So what happens is when the motor turns on, air inside this enclosed area will be sucked out, and it comes out from here. This is the opening, so it's exhausting the fan out from the enclosed area. So let me start off with my presentation. First of all, when there is gas detected in the classroom or in the area, so the fan will turn on, blowing air, sucking the air out, and then my air vent will open up for 10 seconds and then it'll close. I'll do it one more time. So it opens up the air vent, sucking the air, and it closes after 10 seconds. Next, when the humidity sensor exceeds, when this humidity sensor exceeds 80%, my system will run again. I'll show you by blowing air into this sensor. So when my humidity exceeds 80%, my whole system will on again, the fan and the air vent, and it will close after 10 seconds. Close. Lastly, I have a manual push button to manually ventilate the air out of the area. So there's a button here. Once I press the button, my whole system will run again, exhausting the fan and opening the air vent for 10 seconds. So my last feature is a safety feature. So whenever a process or the exhaust motor or the vent is open, it can terminate, it can stop the power supplied to the motor and the air vent. This is for safety purposes. Let me show you. So let's say my motor is running, my air vent is open. As I press this, my motor will completely stop running. This is for maybe during maintenance and stuff like that. Yeah, that's it. Thank you.
My name is Tan Xuan. So here is my system, which is a smart entry attendance system. The problem statement of my system is education institution increasingly facing challenge on unauthorized weapon on campus and manual attendance tracking inefficiency. So basically my system will be using Google Sheet to do data logging on student attendance. Got two parts. One is register, other part is attendance. So for my system, I'll be using the button module to control the switching mode between these two. One press will switch back to register, another press will get switch back to attendance mode. My system in default is in attendance mode. So I'll show you how to register the cards. Switch back to register mode first. Use the RFID cards, register, getting UID. And here what will happen. The AID will appear. And then now you're able to register your student name. For example, after register, you're able to take attendance. Switch back to attendance mode. Use back the same cards with the same UID. Getting UID. This is the LCD display. And green LED lights up, door open. And then just now is the time in. You see here also showing the student entry time, which is the current time. So another scan will be recording the timeout. You see now is the timeout. Same thing happened. Here also recording the time. Current time. So since there are already record of time in and time out, with the same card again, it will show you have completed your attendance record for today. If I use another card that have not registered before, this will happen. The buzzer will trigger, the red LED will light up, and the LED will display error message. So now what if I use back the same card again to register? Register. It will show UID has been registered in this row. So now I'll be testing on the metal detector. If a metal, the red LED will light up, buzzer will be triggered, and also the LCD display a metal detector. So basically, this is how my system works. Thank you.
So this is for when fire is detected. So as you can see, the sprinkler system activated. The emergency lighting is also showing for the students to find their way out. and the LCD will display emergency mode status fire. The buzzer alarm also sounded just now, so this will go on for 30 seconds to give the students time to evacuate.
Okay, so this is what happens when fire is detected. Door opens, fire detected, motor off, fan off.
This is what will happen when fire detected. My sole motor will remain on, and then my buzzer will also been triggered, and then red LED on, and then my LCD display will display fire alert. Evacuate immediately.
So this is what will happen when there is fire detected. Fire detected, and the exhaust fan will turn on, and then it will suck the air out from the classroom in here. So this is what happens when fire is detected. Fire detected. Door open. Fan stop, door open. Sprinkler system activated. So this is what happens when there's dangerous gas present. There's gas. My exhaust fan will turn on, so it's sucking the air out. And then there's a fan here that will open up. And it will close after.
And this will happen when smoke detected. The sole motor will remain open, which means my door will remain open, and then buzzer will be triggered, red LED will on, and then LCD display dangerous gas, evacuate now. Okay.
So this is what happens when gas is detected. Dangerous mode detected, evacuate now. So door opens, and fan turns off.
So this is what happens in my circuit when dangerous gas is detected. The buzzer will sound 5 times as it just did, and the emergency lighting system will show, and the LCD display will show dangerous gas, please evacuate now. Students can evacuate following the lights.
When gas is detected from my circuit.
Wireless detection.